Hello, welcome everyone, and thank you for joining us. I'm here with Luis Serrano, who's the head of developer relations at Cohere, as well as he's pretty well known for his YouTube channel, Serrano Academy, which I'm guessing most of you are familiar with. If not, you should definitely check it out. And I'm Salwa Nur Mohammed, the founder and CEO of Fourth Brain. Luis and I go way back, so I'm really excited to have him here today. He has a pretty impressive resume, I'd say. I'm not going to read off of it, but he's been involved in quantum AI research at Zapata Computing recently, as well as various education initiatives at Apple, Udacity, and Google. So welcome, Luis, and I'm going to let you take it away as you tell us more about how LLMs can be used for business, and we'll follow along.
Thank you so much, Salwa. It's a pleasure to be here with you and Molly. Yeah, we do go way back to a time at Udacity when you were the VP and I was making content there. So it's nice to follow you at Fourth Brain. It's a great place. That's great education initiatives. So yes, I'm very happy to be here, and thank you to everybody who's joining. As a matter of fact, I'm going to share my screen. Now you see my screen here, and I'm going to share my presentation.
Perfect.
And I actually see, this is great because I did have my first question was, hello, where are you joining us from? And I see that people are already joining. It's Alejandro's from Mexico, and Aburku's from Istanbul, and Minneapolis, Monterrey. So great. Yeah, just feel free to let us know where you're joining us from. I live in Toronto. I'm originally from Colombia, but I am in Toronto, Canada right now, and very happy to talk to you about large language models. So as I said, I see the chat. Feel free to ask any questions in the chat. Some of them will be answered right away. Some of them will be flagged for answering later. And there's a lot of people from everywhere. India, Spain, Chad, Pakistan, South Africa, Toronto, Germany, Bengaluru, UK. Wow, that's amazing. I'm so glad that we're all over the place. Philippines, Nigeria. So yeah, super happy to join you here. We have both channels, right? We have the Fourth Brain channel and my channel as well. So let me start talking about LLMs. So, unless you've been living under a rock, you must be aware of this amazing new thing. Pretty much every 10 to 15 years, something huge happens in technology, right? We had the personal computer, then the internet, web browsers, then mobile, cell phones, mobile apps, and now generative chat is definitely the thing. It's definitely revolutionizing the way we interact with computers, because now we can actually talk to them in our language and they talk to us back. So it breaks a huge barrier that we used to have before. So basically, what comes from this is huge, and we're just basically scratching the surface. This is probably what you've been seeing. We talk to the computer, and then the computer talks back. So it's kind of like a brain that just listens and then talks back. I kind of want to dispel this notion and make one small change here, which is instead of one brain, we have two brains. So the brains are one that understands and one that talks back. So the understanding part of the language and the generation part of the language. And if you were, around in looking at AI 10 years ago, this is understanding is what was big. When we started to understand that the computer was happy or sad, if the sentence was happy or sad, or if it referred to spam or not, or if the image had a dog or not. Remember, like when these started coming up, and we were amazed. And now we have the generation, which is even more amazing. So those are the two, and I'll tell you a little more later about the Cohere endpoints. At Cohere, I'll tell you more, but we have a bunch of endpoints that you can use with API that are embed, cluster, rank, classify, generate, chat, summarize, and RAG. I think I'll mention like half of them or more in this talk. But basically, all of them are either language understanding, like embed, cluster, rank, or generation, like generate, chat, summarize, etc. And I'm going to start with what I think is the most important thing, which is embed. Embed is really the bread and butter of large language models. It's really where the rubber meets the road. And what is embed? Well, it's something that turns words into numbers. And why is that so important? Because humans, we speak in words, and computers, they speak in numbers. So whatever we do, we have to translate at some point. And the better this translation is, the better this bridge is, the better that the better things we can do. So like if somebody comes up with a better embedding tomorrow, all language models will be better immediately, because it's really where the translation happens. And basically it's a word gets sent to a bunch of numbers and some really nice properties that they have. Looking at the chat, and somebody's from Tatooine. Wow. Nice. All right, so here is a quiz for you, right? And the quiz is, you're going to help me, so please put your answers in the comments. I'm going to locate a bunch of words in the plane. So on the top left, I have some tennis ball, soccer ball, basketball. On the bottom, I have houses, castles. Then bottom right, we have a bike and a car. And on the top, we have a strawberry, banana, etc. And the question that I have for you is very easy, but I want you to interact. Where would you put the word apple, right? Would you put it in A, B, or C, or D? So I take answers from the comments. Would you put it in A, B, C, or D? And obviously there can be more than one answer, but there's one I'm going for. But yeah, please go ahead and answer. So I hear top right. Yes, I see a C. Yeah, I see a bunch of C's. And that's kind of what I was thinking too. I would put the apple in C. And yeah, I see other suggestions as well. So a lot of things are valid, but I would do C. Why would I do C? The reason why I would do C is because, yeah, I see Quentin Quarantino. That's a really good, that's a good name. A good suggestion, which is A, because it's round. So yeah, we can start seeing that embeddings have ambiguities, right? So it could be A because it's round, but let's go for C because it's a fruit, like most of people say. And the reason it's a fruit, the reason it's C is because it's a fruit, and we kind of want fruits to stick together. If I had a pickup truck, it would go close to the vehicles, and if I had an apartment, it would go close to the houses, etc., etc. And that's one property of embeddings, right? And why am I saying that words go to numbers? Because here there's two numbers for each location, right? It's the horizontal coordinate and the vertical coordinate. So if cherry is 52 on the x-axis and the horizontal axis, and 24 on the vertical axis, and apple would be 50 and 25, and then house is 10 and 4. So you can see the first property of embeddings, right? Which is that that similar things go to similar numbers. And I don't have to have two. I can have words going to 1,000. 1,024 is actually the latest embedding we have at Cohere, has 1,024 numbers for every word. And the ones for apple are similar to the ones for pear, and very different to the ones for car and truck and building and all that. So these embeddings are very very important. They take a lot of building them takes a lot of work. But luckily they're already there, so you can start using them, right? I can give you a demo later of an embedding, but you can actually start plugging them in and doing your models with these really good embeddings. Somebody did point it out. We already started seeing the ambiguities here, right? Because apple could also be round. So here, let's actually have another quiz. This quiz shows a little bit of the ambiguities of an embedding. I have on the top right a bunch of fruits, and on the bottom left a bunch of technology brands or technology words. I have Windows, Android, I have a phone, and that thing is a laptop. Where would you put the word apple now? In A, B, or C? So I take answers in the chat now. Would apple go at A, B, or C? All of a sudden got a little harder, right? Devin has a question. It says, do vector closeness means cosine similarity? Yes, it would be cosine similarity. In this talk, I'm going to pretend it's distance because at the end, the higher the distance, the lower the cosine similarity. But yeah, it would be cosine similarity. So we have a lot of answers, A or C or B. Some people say A and C, and some people say B. Some people say A, some people say C. So the answer is, if we can figure it out, neither can the embedding, right? Like it could go on C because it's a fruit. It could go on A because it's a technology word, or it could go on B because it's undecided. But this shows that embeddings are not perfect, right? Embeddings have their own problems, which is sometimes words mean two things, and the embedding has no clue where to send them because they mean two things. So let's just pretend that we put it in B. And so the question is, what can we do to know what I'm talking about? If I say the word apple, if I just stand up and say apple, what did I mean? And then what we need now is context, right? If I say apple by itself, you don't know what I'm saying. But if I say Apple unveiled this new phone, you know what I'm talking about. I'm talking about the brand. If I say buy an apple and an orange, I'm probably talking about a fruit. So context pulls, right? And quite literally context pulls, because what happens here is that the word apple gets pulled by the word orange. And the word apple here gets pulled by the word phone. It actually gets pulled by all of them, but one particularly pulls them. And I imagine this as gravity. I imagine this like basically you have a bunch of fruits here, and the orange actually pulls the apple and moves it towards it. So now we change the numbers for the apple. The coordinates are different for this apple. Now they're like closer to the orange. And if we do this many times, the apple's going to move to the fruits. And if we're talking about the phone, then the phone pulls the apple there. So we're changing the numbers that we use, because every model will use not the word apple, but the coordinates that it has. And so if we move it, if we gravitate it toward the words that are there. So for example, if I've been talking about fruits for hours, I have a really strong galaxy of fruits here. And if I say apple, well, that gets pulled to the fruit. So I'm talking about the fruit. I'm not going to elaborate too much. This is called attention mechanisms. It's really what made language models work. I see some good questions. What about a BlackBerry? I think it's the same thing. Actually, somebody pointed out to me that Orange is a brand of phones in telecommunications in Europe, so that I have to change that example too. But I feel like the ambiguity is too much here, so we have to kind of pretend that things are more simple. Anyway, this is called an attention mechanism. This gravitational thing is called an attention mechanism, and this is really what made transformers work so well. Because a few years ago we had models that would be able to find the next word in a sentence, but they're very simple. They didn't really carry context. Attention is what made these models carry context. This is the architecture of an attention model. The Cohere model, the ChatGPT, and any of those models has pretty much this architecture, where here you can see the embeddings, right? The embeddings that I told you, the plane. Here you can see attention happening a bunch of times. And here you see a neural network. So this neural network, basically, I won't say much about it, but I'll give you a reference pretty soon. But this pretty much is what we've seen for a long time. When you go on your text messages and you type "hello, how are," and it suggests the next word, that's pretty much the neural network that is used in transformers, of much bigger. But it just guesses the next word that's coming in the sentence. Now those don't work really well, but if you pad them with embedding and attention and a bunch of things, then they start working really well. And that's a transformer. Basically, it just guesses one word at a time, and it can form a huge story, a huge everything, but one word at a time. I see a question by Khaled. Does the embedding train separately? Yes, they are trained separately. They're trained in several different ways, but yeah, they are trained separately and used here, and they can be used in many other applications. As a matter of fact, today I'm not going to talk about transformers fully. I'm going to talk about search, where embeddings get used. But I just dropped a single today in my channel, so this is a great time for joining this transformer models. If you go to my channel, there's a transformer models where I explain all the stuff about transformers in detail. There's actually 3 videos. There's 2 on attention and 1 on transformers. So it'll give you all the information you need on the channel, Serrano.academy. Definitely check it out. And as I said, today I'm not going to talk so much about what transformers do, but I'm going to give you a really cool application, which actually is search. But before I get to search, I'm going to tell you more about embeddings, because embeddings are even cooler than what I just showed you. See, I showed you that a word goes to a bunch of numbers, but not just a word. They're actually called text embeddings. So an entire sentence, an entire paragraph, and even longer stuff can be sent to a bunch of numbers. So for example, here, so this is actually, I took a screenshot of the demo that I'll give you later, is the Cohere dashboard. You can write sentences and make them embed and play with them. I put these 4 sentences: hello, how are you, hi, how's it going, which are similar. And then the car is red, the vehicle is blue, which are similar. You can see similar sentences, right? Even though they don't have the same words. And the embedding picked up that 1 and 2 are close to each other, and like 3 and 4 are close to each other. So you can put longer pieces of text, and a good embedding actually sends the piece of text to a bunch of numbers that have the same property. They're similar. They're close if the numbers are similar. And as I said, it's not just 2 numbers, right? I can send each sentence to 1,024 numbers, and these things work like magic. And at the end of the day, what I like to see if an embedding is kind of a summarization of the text, right? Like if I have a sentence and I send it to 1,024 numbers, it's almost like each number has a description of something, right? Like if it's a fruit, if it's an apple, and it goes, maybe 1 number tells you about the sweetness, and 1 tells you about the shape and the size, or maybe even properties that the computer knows and we can figure out. But at the end of the day, think of 1,000 numbers that describe your thing. So obviously, if the 1,000 numbers that describe an apple and the 1,000 numbers that describe a pear are probably going to be similar in some way, right? And here's another example, an experiment that I was playing with. There's a huge data set of sentences, and I send it to an embedding, and this one doesn't have 2 or 1,024. It just has 10 numbers. So 10 numbers associated to each sentence, and the numbers are seen as shades, right? Big numbers are dark, small numbers are light. And then take a look at these 2 sentences. Show me a list of ground transportation at Boston Airport, and show me Boston ground transportation. And they're very similar. And as you can see, the numbers are pretty close to each other. They're not the same, obviously, but they're very, very close. So you can see that a good embedding sends similar sentences to similar numbers, a list of numbers. It's called a vector, actually. And that's a line of text. That's a line of code. In the Cohere endpoint, you can just say code.embed and then put in your text, and out comes a vector of 1,024 things. So it's pretty convenient. It's a very powerful. The very powerful models are used for this, but all you have to do is 1 line of code. Yeah, and then there's also a multilingual embedding. There's a multilingual embedding that supports over 100 languages. And I did an experiment here. I said, hello, how are you? And bonjour, ça va, which is the French sentence. And then the car is red, and l'auto es rojo, which is the English and Spanish sentences for the same thing. And the model catches that, it sends things in different languages to similar numbers. So it pretty much takes all the languages and translates them to numbers in the same way. So the computer doesn't even care what language you're talking. It just picks up the numbers and it goes, okay, I'm going to work with these numbers. And, so yeah, let me make a small time and see if there's any questions. Inigo says those 1,000 numbers are dimensions. Yes, they are. Khaled says embeddings are good when they get more than 3 dimensions. My mind blowing up. The same happens to me because I can't visualize them. You can also visualize 3 dimensions, right? But if you visualize 1,024, just picture words flying around in 1,024 dimensions. Lorenzo says number related to distribution probabilities of words learned during training. Yeah, there are some. I would say they're more like properties of the word, but yeah, you can think of things in terms of probability distributions. Okay, so let me go to the topic of today, which is search. So let's talk about search. Search is very, very important in large language models. And I'm going to ask you a question just to see if I get some answers here. How would you build a search engine? So why don't somebody maybe give me an idea of how would you build a search engine? If your boss comes in and says, hey, we have 10 minutes, I need you to build a really quick search engine for our documents. How would you how would you go about it? And if obviously a simple answer, because you have 10 minutes to do it, so you can't come up with the best search one algorithm, but what's the first thing you would try? I'm gonna answer some questions. Dino says, do you use Word2Vec? Yes, Word2Vec is used. Keywords, regex, embeddings, and keywords. Wow, you got all the you guessed my talk. Yeah. Have embedding database, convert query to embedding, finds nearest neighbor in database. Wow, you all know a lot. Yes, very good job, everybody. Yes, that's what we're gonna do. We're gonna do first the first suggestions that I got, which are keywords, and then we're gonna use embeddings. So wow, this is a very educated crowd. I see a lot of great answers. So thank you all. So let's go with the easy one. Let's go with the keyword search, which is really matching keywords, right? Like I'm going to take, for example, I'm going to search Brazil to USA travel visa. This is what I want to search. And if I search for something that matches as many words as possible, because that's keyword search, right? I just find the answer among an answer database, the one that has the most amount of matching words, and then it gives me USA to Brazil travel visa, which actually matched perfectly because it matched all the words, but it didn't capture the answer because I wasn't looking for USA to Brazil travel visa. I was looking for Brazil to USA travel visa. So the perfect answer for keyword search, but a bad answer for what I wanted. So instead, I'm going to look at more answers here. Yeah, a lot of embedding, algebra, linear algebra, proximity of vectors, ranking stuff. That's actually pretty good answer. That's coming too. Hashing to embedding, normalize by projecting to the embeddings, information through documents. Yeah, you all have great answers. So basically what we want is something better than keyword search, right? So what's better than keyword search? Well, something that actually doesn't have to match every single word. It may not even match a single word in my question, but that actually captures the context, right? The semantics. And that would be semantic search. So I'm going to show you what semantic search is. I'm sure a lot of you already imagine what it is. And what it does is it basically embeds the questions and the answers. So it puts them all in an embedding. This is the embedding. And obviously, Brazil to USA travel visa and USA to Brazil travel visa are far because they're not the same meaning. A good embedding would capture that these mean different things. Whereas these two are close because even though they don't have the same words, a good embedding will capture that they're both very similar meanings. So it puts them close. And then all I have to do is nearest neighbors, right? I just pick the closest answer, and that's my answer. So that's dense retrieval. Dense retrieval pretty much has a bunch of documents, answers or paragraphs or articles in Wikipedia or anything. And it puts them all in an embedding, and then it puts the question, puts the query, and then finds the closest one. And among those, the answer should be in principle, right? So super simple example here. I have 4 sentences, and this is a demo. I did it on the dash on the playground as well at the Cohere playground. I put the capital of Canada's Ottawa. Apples are red. Galileo invented the telescope, and a square has 4 sides. That is my data set of answers. And then I have a question, which is what is the capital of Canada? And I embed that, and in the embedding, it goes here. So obviously, the closest is the capital of Canada's Ottawa. And so that's my dense retrieval. That's how I found it. So if you have any questions, feel free to put them in the chat. I have a question for you. What could be potential problems with dense retrieval? Let's see what could be a potential issue. Like this is obviously not perfect. It's better than keyword search, but when could it go wrong? Where could dense retrieval go wrong? Victor says meaning, speed could be meaning, retrieving another query. Jan says, yeah, those are all correct. Actually, retrieving another query would be the a big problem, right? Because slow processing could be too, but it can be speed up. Limited to the actual knowledge base. Yeah, that could be bad or also could be good, right? Because it could restrict it to what you actually want. Misunderstanding context, that can happen. Yeah, false positives to nearest neighbors, biases. Yeah, a lot of great answers. I'm going to tell you one problem with it. Yes, there you go. Diptychalion. Thank you. Similarity is not always the answer. That is correct. And Ali also says dense retrieval looks for the same meaning, but it doesn't necessarily answer the question. There you go. You nailed it. The closest sentence is not the answer, right? If you ask me, what color is an apple, and my answer is what color is an orange, well, you say, well, that's not the answer. I say, well, that's the closest sentence, right? Because the closest sentence is not the answer. And I did a little experiment here where I said the capital of Canada is Ottawa, the capital of Canada is in North America, the capital of USA is Washington, and the capital of Canada is in the moon. Some of them are true, some of them are false, some of them are completely unrelated. But the fact is that if I put the question, what's the capital of Canada, it can be as close to all of them because it's similar to all of them. And as a matter of fact, the one that was closest was the capital of Canada in North America, which is it's a similar sentence, but it's not the answer. And so, yeah, I see a lot of more answers that here that are in the chat that are correct. Once it's similar is not relevant, which actually is good because relevance is what we're looking for. And so at the end of the day, what I want is if something's an answer, not if something is similar. So what do? We get to re-ranking. So re-ranking is how we solve this problem or how we improve it a lot. And basically the idea is this. The idea is that maybe the answer is not the most similar sentence, but if I pick the 100 most similar sentence, chances are the answer is there. So if I go from there, then I can, there's an endpoint that we have called re-ranking, which gives it a relevance score. It takes pairs, question, answer, and gives it high relevance scores if they're similar and low relevance scores if they are different. Jorge says like Watson in Jeopardy. Yeah, maybe that's is that how it works? That's cool. So yeah. So therefore, the re-ranking assigns high relevance scores to pairs where the answer is very relevant to the question, and it works really well. Here, it assigned the highest relevance score to the actual answer. So what we do is we use semantic search or keyword search to surface a bunch of potential answers, and then use re-rank to rank them and pick the best ones out of there. And that's also a line of code. Co.re-rank. Then you put the query as a string, and then a list of the documents. Could be answers, could be longer pieces of text, etc. And then it re-ranks them all. And when you combine these two, you get semantic search. So you first do dense retrieval, and then do re-ranking. Of course, you can use anything for dense retrieval. You don't have to use for the search part. You can use keyword search, right? You can use any OK search you have, and then improve it with re-ranking. I get this question often, which is why don't you just use re-ranking from the beginning, right? Why don't I just re-rank everything? And the answer is that re-rank is more expensive and slower. So if what I have to do is surface the best ones and then re-rank a small set, 1,000 or 100, and that works much better. All right. So I'm gonna maybe take a little pause and see if there's any questions, because I'm gonna switch topics. Oh, and in case you have the question of how do we train this model, it's basically a big neural network that you train with pairs that are question and correct answer and give them a high score, and pairs that are question and wrong answer, and you try to trick it by saying similar questions, similar answers that are wrong, and then train them to give low scores. And this actually model works really well. There's a lot going on in the background. Okay, maybe I'll do the questions a little later, and I'll go here because I'm close to running out of time. Here is a question for you. So we saw chatbots, right? And we saw search. And now the question is, what is a common problem that chatbots have? So I'm gonna let you put things in the chat. I'm going to repeat this answer. Gary asks, how does the re-ranking algorithm work, and is re-ranking a human task? The humans definitely input stuff. Like you get a curated data set of question answers that are good and question answers that are bad. And with these two huge curated data sets, you train a big model to assign high scores to good pairs and low scores to bad pairs. That's pretty much the way to train a re-ranking model. I start seeing answers from several people who say that the big problem is hallucinations, right? They don't understand, they don't say the truth, they say a lot of, a lot of wrong things. Basically, these things can talk really well, but they many times don't tell you the truth, right? They make stuff up, and it's dangerous because they're very confident, right? They're like that confident friend that we have that doesn't necessarily know a lot of stuff, but they're always confident with the answers and explain stuff very with high confidence, but they don't say the right thing, and that can be a problem, right? So the question is, how could we fix that? Can anybody help me fix that problem? Like, how could we help that friend? We have a friend that likes to answer questions but doesn't know everything. How do we help that friend answer questions more correctly? Let's see. Yeah, correctly. It's confidently wrong. How would you fix? How would you try to help a model to not hallucinate more? And Srikant has the answer. It's RAG. Our LHF works too, yeah, to train the models. This is how the models get trained, but more yeah, verify mask again, yeah, lower the temperature, prompt exchange, yeah, there's a lot of things. Confidence score could work really well. Ask the friend 1,000 times, that's pretty good. Yeah, get free from using. Okay, I see a lot of great answers. I'm gonna tell you one, which was mentioned here, which is RAG. RAG is retrieval augmented generation, and it really says you first search and then answer from there. So your ultra confident friend, you ask them a question and you say, but don't answer this question. Here's a book, and there's in this chapter there's the answer. So answer my question based on what you read from this chapter, and that's it. Don't answer anymore, just from there. And that actually works pretty well. So that's retrieval augmented generation. So here, a small exercise. This is very easy. If I were to ask a model a question, who won the UEFA Champions League in 2021? That's question one. And question two is, who won the UEFA Champions League in 2021? But I'm also going to give you a paragraph where the answer lies there. Which one of these two is a better prompt for the model to be able to answer? Prompt one or prompt two? And I think we already answered that question, right? It would be prompt two, because it's much better to ask the question and give it somewhere where the answer lies within. And so it's question two, as people are already starting to reply. And that's what happens, right? Because if I try to store information in a model, that's not good. Like, these models know how to talk. They know how to pick up things like sentiment or sarcasm or anything like that, but they don't know how to store information. Storing information in the nodes of a neural network, storing dates and places and stuff like that is not the most reliable. So you wouldn't want to store it in the neural network. You'd rather have the neural network focus on talking and following orders and following commands, and have the world information somewhere else and look for it in the database. And how do you look for it? Well, with search. So if you combine search and a language model that talks, you would have a much better model that doesn't hallucinate. Here, I'm going to give you a demo of Coral, which is what it does, right? Like it basically answers the questions from search, and it gives references. So it says, actually, from here, this came out from this link, and that came from that link, etc., etc. But before I give you the demo, now I can go back and be like, okay, this is what I mentioned first, right? That Cohere has a bunch of models. Half of them go for generation and half of them go for understanding, which is embeddings. And what do we talk about today? We talked about generate and chat, which are the chatbot, right? The generating model. We didn't talk about summarize, but it's a model that takes a big text and summarizes into something smaller. Chat plus RAG is the one that searches and then responds. We didn't talk about cluster classify, but we did talk about embeddings and re-rank. So basically, feel free to play with the playground. I'll give you the link pretty soon. And the demo I'm going to give you is Coral, which is the sort of the chat, the chat endpoint. So let's do a quick demo. So let me show you. You go to the Cohere. You go to the dashboard at Cohere, and then I can put a lot of sentences here, but I'm gonna just take a preloaded data set of subreddit titles, and I'm gonna say embed, and it just embeds them here. It always does something different, and it embeds it in 2 dimensions, but in reality, it's in 1024 or perhaps even more. But it brings it down to 2. So as you can see over here, I have some news about Queen Elizabeth and England. Over here, I have some politics, European. Here I have some things with oil. As you can see, like they go, similar things go to similar places. These are more like family questions, etc. So that's embed. And I also want to show you Coral. So let's actually do a live question, something very recent. Let's say, who won the 2023 Rugby World Cup? I don't know a ton about rugby, but I do know who won. So, and it's something pretty recent. So it's something that here's where I say augmented with web search or don't. So if I don't augment it with web search, it doesn't know, right? It says that not been determined. Determined hasn't taken place yet. It doesn't really know because it's too recent. And sometimes it will say, I don't know. Sometimes it will make up some answer, say something completely wrong. But now let's do the same thing, but instead we say, well, now I want you to use web search. So first search on Google and then answer the question. And when we do this, then it says, there you go. It answered the correct answer, and it also gave me links. So I look at this, and it tells me it tells me where it found it in the links in ESPN or something, and I can ask some more. Where was the game played? And it will tell me, right? Come on. Actually, is that true? I don't know. But anyway, so that's the idea, right? It tells me where. It tells me what links came from. So it shows it works. So it reduces hallucination a lot. So that's what RAG does. I think that's all for that I'm going to tell you today. So before I'm going to give you some resources if you're interested in more stuff. If you want to learn more about this, I super highly recommend you a course that we are building that we build at Cohere. It's called LLM University. It's a team of content developers that are great. I love learning from them. And this is a pretty comprehensive course. LLM.university is the link. I'm gonna put it here. LLM.university. Check it out. It's got everything. Code labs. It has prompt engineering, search. It has how do LLMs work, all the stuff. Also, we have the Cohere blog. Check out the blog. I write stuff there often, and there's some great updates there. The dashboard I already mentioned with Coral, that you can go in and make an account and play with it. You can also have a trial key if you want to get the API account and get the account for doing API calls. So I highly recommend it. The API, the trial has a lot of keys you can use, a lot of API calls. Definitely, if you haven't, please check out my channel, Serrano.academy. I have a lot of videos, especially the one on transformers that I just dropped in this morning. These are a bunch of these I have on attention, mechanisms, etc. So definitely check it out. And my colleague Jay Alamar has an amazing blog where he has a lot of articles about transformers. Definitely check that one out. That's where I go to learn transformers. So yeah, I think that's all I have. So thank you very much, and I'm taking questions. And I know Salwa has, I think you
Yes.
applied with future events. Do
Yeah,
you
I
wanna
do
share
have
it?
some future events, so
Yeah.
let's throw that up. And what we have here are some workshops that are coming up with Fourth Brain in this upcoming month, and you'll see the dates right here. One is building generative AI applications that is conducted over 2 days, 3 hours each. And then we have one that is kind of top of mind. We've heard from a lot of people ask about this. And after I get through the slide, Luis, I'm going to kick us off with questions around this, is about using proprietary data. So essentially security and privacy around data and using public LLMs or open source models. That's on November 10th. LangChain, we're doing one that's building your chat GPT for your own data using LangChain. That's coming up on the 13th. So you can see quite a few. The building generative AI one is the most, is the closest one that's coming up literally next week. And then we also do a workshop. This is actually not super technical. It's meant for executives and leaders who are thinking about how to apply generative AI to their businesses, and whether that's to develop more AI first products or to think about operational excellence and efficiency. And that's coming up on December 1 and 8, which again is 3 hours each and split over 2 weeks. So yeah, we'll keep the slide up here for a little bit. If people want to check it out, you can also go to our link under programs and see all of these upcoming workshops. Thank you so much, Luis. This was super
Thank you.
informative, very knowledgeable. I always learn something from your talks. So I wanted to kick us off, and you can see like there's quite a few questions and comments coming in, so we'll keep them coming. We have a few kind of, don't worry if you've asked those questions prior, we did star them and I have them in a section for you, Luis. But I wanted to kick us off to ask your opinion around this concern that a lot of, whether it's individuals or companies, or now the generative AI is a little bit more mainstream, there are organizations, whether it's law firms, pharmaceuticals, biomedical, that are thinking about, okay, we want to use this, but what do we do about data privacy and security, especially if they're using their own data and they're trying to use LLMs. So how would you advise folks to get started, or how should they just think about security and privacy when it comes to using LLMs?
Yeah, definitely security and privacy are the most important. That and fairness and bias and things like that. Those are the main concerns. In terms of security, we're very like focused on that. So we actually have like these models can actually be deployed on any cloud environment, and it can be deployed privately. So if a company has their own stuff on AWS or Google Cloud or something, they can actually see the models. They can actually use the models in that cloud, and it's very important that like we don't see your data or so yeah. I mean, I would say that the biggest the responsible. I would say that for anything that in LLMs, the responsibility sort of falls on everybody. The people building the models, like Cohere or these companies, they have to make sure that your data is private and not seen by them or and nobody else, right?
Mhm.
And then the people building apps and building models also have to have a responsibility of keeping this data private. But yeah, I mean, as long as you have an environment where where the model is run privately in your cloud, that I would say is the best thing.
Great. Thank you. I'm going to pick out a couple questions here that have come in over time. So they may seem a little out of order. One question from Garib was around, how does the re-ranking algorithm work?
Yeah. So how it works, like how to use how for serving is very simple. I just put in a question as a string and then a list of strings that are the documents, and it's just gonna return the relevant score for each pair, question answer, and then I just take the biggest ones, and very likely the answer is gonna be there. So serving very easy to use as an endpoint. And as for training, yeah, you have to do is you take a large data set of correct question answers and a large data set of incorrect question answers. and try to make it very tricky, right? Try to make it so that the question answers are very close, but they're still incorrect. And then train those to give very low scores, and train the correct pairs to give very high scores. And like as mysteriously as big neural networks are, it starts picking up what's correct and what's not, and it works really well. That's pretty much the how it works. There's other methods too. I mean, you can also mess with the embedding a little bit. You can take post train your embedding to, like, correct pairs get closer, incorrect pairs get farther. So many things you can do, but we've seen that re-rank is just so simple and works so well that just kind of go with it.
Right. So kind of following along, I know someone here, Dr. T, asked a couple questions, but I'm going to use the one that came up a few times, is how do you tell the model where the answers are? And then how do you get the answers to actually provide to the model?
How do you tell the model where the answer? Okay, great. Yes. I mean, normally this could be as big as like search on Google or search on Wikipedia, in which case you just let it do all the search, and then from there pick the answers. But a lot of these things are used privately, right? Like if you have a bunch of instruction manuals in your company and you want a chatbot that only answers about those, and then if you say anything else, it just says, I don't know the answer, then you can restrict to your domain, right? And there's two things you can do, right? There's two things you can do. Let's say you're a company and you have, a bunch of PDFs, a bunch of things manuals to answer questions. So you can take a transformer model and post train it with your data. So you can overtrain it with only your data, and that will make it better to answer questions for your data. But then you also make it search on your data before you get a question. Like when you get a question, you first search it and then give the model the question and a bunch of places where the answer could be. And they say answer from here. And that we've seen that is the best results. So basically, you decide where the data comes in. You decide from where do you want the answers to come, normally from the database that you have.
Great. I'll ask one more kind of technical specific question, and then there's some that are about education, which I know you and I both really care about.
I was hoping you pick those. I know you'll pick those too.
Yeah,
Yeah,
so I'm going to save one for the end, but I'll ask one right now. What do you think about using LLMs in educational technology?
I love it. I absolutely love it. I mean, I think anything that helps education, of course, we have to make sure it's accurate. But I think it's wonderful to have a tutor that can answer questions all the time. And you still have the human model, right? You still have the human helping out, but for a human not to like repeat the same answer many times, you can serve a lot more people. You can
so like the tutoring applications.
Yes. Tutoring applications and a lot more stuff. I mean, there's I've seen companies that pair tutors with students using AI. There's so many things. Actually, you know so much more about this than me. Why don't you?
The possibility with scale is like very exciting to me, I think. And
Yeah.
then the other things that I've seen that are kind of new coming up are around this idea of coaching. And I say coaching with air quotes because it can be anything from career coaching, other types of coaching. So, because pairing up mentors and coaching, as you said, it's one of the hardest, I think, things to do in education. So the possibility of scale there is pretty exciting. Okay, I'm going to jump back into another technical question. For a generalist search engine, since that was the thing we were demoing, the curated data set should be done all on human knowledge. How does it work in practice?
For the training, yes. I mean, I would say even more than just search. Like for training these models, first you train them on the internet, but then that's pretty, like, the internet's got all over, knowledge, but it's also got a lot of wrong stuff, so you need to train, like post-train things on curated data sets, and these are basically done by humans. And that's where I would say one of the most expensive parts of training a large language model are, which is in creating all this correct data, which can be like data of questions, answers. It can be data of like commands and like and doing the command, right? Like, give me this, and then it does it, or chats. So yeah, you have to create you have to like create all these data sets, and they're created by humans, and sometimes humans that know a lot about a certain topics. It's created by experts, and then you would use things like reinforcement learning, RLHF, human feedback,
Mhm.
to be able to use that data to train your model. Um, did I actually answer the question? I forgot what the question was. It was about.
The question was about how, in practice, does it work to train a curated data set on human knowledge?
Yes, yes. We have lots of annotators. All these models are trained with lots and lots and lots of annotators, and it can be as much as like writing stuff, writing the data sets, but also many times like the annotator would just go and be clicking, right, and be like, okay, which of these two answers is better? This one. Which of this one's better? This one. Which one is more relevant with the question? This one. So there's tons and tons of human feedback, and as I said, reinforcement learning human feedback is the main model that is used to feed that information back into the model.
Got it. Okay.
Yeah.
One more here. Ritesh asks, how do you handle authenticity evaluation?
Authenticity evaluation, that's a good question. What is that? like
That's a
like
good
uh
one. The way
you
I
can
read it
elaborate.
was, if Ritesh, if you want to add that into the comment section, the way I read it is probably verifying sources, but I could be entirely wrong.
Hmm. Yeah, I mean, for searching, verifying sources, web sources. Oh, I see.
Web
Got it. So
sources about
when
yeah,
you do a search on a web and then it's
mhm,
wrong.
right.
That's a very good question. I think you try to restrict. We try to restrict the search, as you see the sports questions I asked. It only picked up from ESPN, right? Like it didn't pick up from other places. So I think you can sort of curate your sources to say what is more things that you trust more. Like Wikipedia would be something I trust more. Um, at the same time, if I like, it's like we do in Google, right? Like when we do a Google search, maybe we don't believe some of the entries, but if we kind of look at all of them, the truth probably appears more. So you can also do so you can do qualitative things, which is like
Mhm.
pick good sources, and you can do quantitative things to see, well, this answer got appeared a lot more than this one, so it may be right. But yeah, it's a challenge. I mean, data is always the biggest challenge, right? Like
Right.
when data's awful, whatever beautiful your model is, it's going to
Mhm.
come out with problems. So a
Right.
lot of questions is go look at the data.
Yeah. And it's also like one of the things I've noticed is it's created an opportunity to kind of come up with products that are domain specific. So, for example, in the legal realm, right? Sources matter for them.
Yeah.
So you can't just go use a public source, a public model that's using all of the data on the internet. So there are products or vendors coming out with these where they verify the underlying resource, and then it's literally marketed as a reliable product because the underlying sources are vetted. And that's a lot of work. Not the ideal way to do it, but it does create opportunity for those kind of like domain specific products where the information sources are vetted.
Yeah, and as an individual as well, like I would say, nobody should go ask the model something and then go trust it completely. Like I've seen problems with like lawyers who use these models for something, and they give very confident but wrong answers. Even myself, like I would always verify it. I use it for my videos as well. Sometimes I say, help me explain this, help me check this, and it's sometimes tell me like wrong things that I that I almost close to putting there, because you just as a human, as a user, always take everything it tells you with a grain of salt and go verify it somewhere else.
Right. Yeah. All right, so we'll take two more questions. So one is, what factors should be considered when choosing a vector database? And what are the pros and cons of using these frameworks?
Vector databases are very, very good. And just to give people the idea, that basically when I said search, when I said put things in the embedding and search for the closest thing, I threw a lot under the rug, because if you have a billion points and you put them in 1,000 dimensional space and then find the closest point somewhere, it's not easy. If you're looking at it, like I can say, well, yeah, this is closer than this, But if you don't, you actually have to look at all the points and compare the distance with all of them and then sort them. It's a very slow process to find the nearest neighbor, the closest sentence to something. It's a very expensive process. Thank God for vector databases. So they yeah so they first of all store things very well, like, so they store all your data, and they also do a really fast and nearest neighbors search, because it doesn't have to search all of it. It does like smart things so that it doesn't have to go through everything to actually search it. It stores it in the right way and has some fast algorithms. So I would say two things in a vector database is, how well it stores stuff, and how fast it retrieves, how fast it does, um, how fast it can do nearest neighbor search. So yeah, I mean, I like a bunch of them. VB8 is pretty good. Like Launching, I don't know if it has. Stuff is pretty. I use some of the pretty good ones. But yeah, maybe you can try different and see which one gives you a better search results.
Great. All right. So I'm going to end on this one because I think this is going to be a favorite question for both you and I. And Ray, thank you for asking this question. I'm glad to see this because this came up. I was on a panel last week about the future of work and teaching AI skills. And this came up quite a bit during that panel too. So there's a lot of discussion in the developer community that machine learning and LLM engineers are transforming into AI engineers. And it's said that in future, people may not start with attention. Attention is all you need. Thoughts around this?
So, say the last thing again, please. What is the attention is all you need? The paper, or
may not start with attention is all you need.
That's a paper
point. That is, yeah.
Yeah.
So thoughts around it, and it's also kind of asking around like moving from a machine learning engineer into an AI engineer, and I'm adding a little bit of color myself here too. Is the questions I have seen around is, what does it mean to be an AI engineer, and how is that different?
Yeah, I think, remember, you and I maybe 8 years ago at Udacity trying to question you, what is a data scientist, right? I think that question always works, and I think everything changes, and whatever predictions I make, maybe somebody will get this recording and be like, look, you were completely wrong. But I think this keeps evolving. These jobs keep evolving. And at the end of the day, AI engineer, machine learning engineer, data scientist is just somebody who knows how to handle data, right? Like, it's somebody who knows how to predict things, how to see trends in data and predict things for others and other data points, and infer from there. And things change. I mean, I think like concept wise, I don't see things changing that much, but like syntax wise, I see, for example, prompt engineer gets more and more trendy now, because what I think is that people will code less, because these models code now can, the communication with the computer is now easier. So I can actually talk to the computer and tell it what to do, as opposed to writing code. So that's more before. And before, people had to use assembly and punch cards, so the communication with the computer just becomes more and more natural with every generation. And what I think, and I may be wrong, but what I think is that probably the next generation is not going to have to write code, but it's still going to have the high level understanding of how computers work and how models work and how data works. So I think the next generation of data scientists is going to be more of that. Is going to be more involved in, like, what the problem is, how do I solve it with data, and etc. And the syntax is going to be less of the roadblock. But what do you think?
Yeah, a lot of, I think, these tools, what is helping us do is it's almost moving the starting point or accelerating things, right? So before, if you had to like really sit down and start from scratch with every line of code, that's already moved up. And this is just taking it further. So what that means for us, I think, as learners is it moves, we're just going to be able to accomplish so much more because the starting point has moved up.
Exactly.
The other evolution, I think, that happens is it's hard to kind of see because the evolution, like things change so frequently, but we've noticed this even within our fourth brain programs, is the need for continuous education is getting redefined, right? It's not this department at a university that no one looks at. That's what continuous education used to be, right? That's not what it is anymore. Like we've moved from having these 3-4 month long programs or having these alternate credentials boot camps to having 1 day, 3 day, 1 week workshops, right? And we see a lot of repeat students. So this, and it came from our students and graduates essentially telling us that, hey, I don't have time to like carve out 3 months and then things move too fast and change. I need more shorter upskilling that keeps happening. So I think that's going to be a big part of, and one of the reasons I think we see these roles getting redefined or the titles kind of becoming nebulous to some degree is people just have to get started. Just to get started, whether it's if you have 1 day, half a day, that's what you do, and then maybe you have a week at some other point. But and the upskilling, I think, is also not going to be for new roles, right? It's not like, oh, I'm in this role right now, I want a new job, I take a course and then go do it. You need upskilling in your existing jobs, right? In your existing role. So that's going to be important as well.
Absolutely. If I may add, yeah, that's a great point, because things change so much that, whatever we'll be doing in 5 years, 10 years, maybe doesn't exist now. So you have to constantly learn. I think the previous generations who were, were able to learn until they were like 22 and then start working for the rest of their life, like that, that doesn't work anymore. And I'm glad it doesn't, because that's awful. But I think it's good that, now we have to be learning constantly. And for content creators like you and I, right, like we have to build the stuff faster, because if I start building a course in large language models and it takes me 1 year, in a year it's irrelevant. So you gotta build smaller chunks and be constantly learning. I'm always taking courses, I'm always doing stuff. It's actually fun. I mean, can't fall behind. We're all kind of catching up, so I think it's
it forces it to be fun. It can't be bored when you have to do it.
Exactly.
So true. Well, thank you so much, Luis, for joining us. I know we all enjoyed the conversation, and it was really nice to see an active kind of chat going on. Would love to have you back at some point, and I know we'll keep working together and talking. And thank you to everyone joining from all corners of the world, it looked like.
Everyone. Thank you so much for the invitation. I'm always a big fan of Fourth Brain and what you do. And so happy to be here, and thank you for everybody. There was such a lively chat and so many questions and so many answers to my questions. So thank you to everybody who was here for making this very lively. Thank you.
Great. Have a good day, everyone.